Today we're going to look at truth tables. Do you ever try to read fine print for financing a purchase? It can get confusing. I took this one from a Rooms to Go advertisement where it talks about the financing, and I just wanted to give you an example of how involved the fine print of an offer really can be. Then I went through and I just circled some of the words that we're going to be talking about in the next few slideshows, videos that we'll be looking at. And you can see I circled a bunch of ands, I circled a bunch of ifs, and that's really what we're going to do is look at how these ands and ifs and ors and stuff really work when we start combining them together. So with any statement, we said a statement has to be true or false. So that's what we want to start talking about is the truth of a particular statement. And what we'll see is this will become tricky when we start connecting them with multiple statements. So to keep track of things, we have a truth table. And what a truth table is, it just keeps track of all of our choices. So for any statement we have, it could be true or false. We also have negations of statements. So remember we have this not P, and it just means it's the opposite of P. So whenever we have P is true, then not P is going to be false. If P is false, then not P is going to be true. So we have these choices here. So now let's put more than one statement together. So I'm going to let my two statements be P and Q. And again, we want to go through all the choices of what P and Q could be. So when are they true or false? We need to consider all possibilities. So to do that, we're going to say, well, what are the choices for P? P could be true, Q could, or false, but Q could also be true or false at the same time. So to get through all of our choices, we're going to do this. For P, we will write true, true, false, false. You can see it in the little chart. And for Q, we're going to write true, false, again in the chart. Our reason for doing that is to get every combination possible. So I have they're both true. I have P is true, Q is false. I have P is false, but Q is true. I have they both false. So doing this memorization allows me to get all combinations without really having to think about it too hard. So I really don't think it's going to take you too long before you'll start thinking this in your head as soon as I pop up a truth table. So what we need to talk about is, well, what happens when I put them together with or? Well, or really only needs one of them to be true. If they're both true, fine, it's true. If P is true and Q is false, still okay. If P is false but Q is true, we're still good. The only time we're going to get a false is when both statements are false. So this is what I circled here for you. The only time or is false is when both statements are false. I like to think or only needs one true to be true. If we switch this over and look at and, we're still going to have our true, true, false, false, and our true, false for P and Q. So here's our basics. But with and is more fussy. And needs everything to be true in order to get a true statement at the end. So in our chart, true, true is true, but true, false, true, and false, false will all be false. So again, I circled and said, well, the only time I get a true statement for and is when they're all true. So or needs one true, and needs all. Let's make it bigger. Let's do both of them. So I'm going to construct a truth table for P or Q and not P. So let's start with my columns. I'm going to need a P and a Q. Those are my basic statements. And then I'm going to do parentheses. Still math class, so we still do order of operations. Then I can put the not P, and then I put the whole thing together. So P is true, true, false, false. Q is true, false. Then we think or. So with or, I need one true. Here's a true, here's a true, here's a true. Those will be true, and then the last one is false. Not P will be the opposite of P. So instead of true, true, false, false, I'm going to have false, false, true, true. Okay. Last column, put these two columns together, but remember it's and. So I need all trues to be true. So true, false will be false. True, false is false. True, true is true. And then false, true is false. Let's add words in there. So take this statement. Angela is an education major and she loves working with children. We want to make a truth table with this. So we first need to make the statements into symbols. So let's let Angela be an education major, be P, and Q is she loves working with children. Now we can make a truth table. And you probably think, well, why do we need to? Well, number one, I don't know who Angela is. Number two, I don't know if she likes working with children. So we want to put all of the different possibilities together and see when is this statement true. So I start with my P, true, true, false, false. Q, true, false, true, false. And then the OR says I need one true. So I have two truths, true, false, false, true. So true, true, true is true, true, true. Then false, false is false. All right, I want you to try. Make a truth table for the following sentence. My sentence is, the team didn't win and won't be in the championship. Here I'm going to go ahead and tell you what I want you P and Q to be, just so that we all have the same thing. So I decided P will be the team won, and Q will be, they will be in the championship. All right, pause the video for a minute, see if you can set up your columns, put in the truth values, and see what you get in the end. All right, so let's check out what I did. I said first, well, I need a P and a Q. And then because I see they didn't win and they won't be in the championships, those are negations. So I have not P, not Q. And the connective is clearly and. So I'm trying to find the truth value of this statement, which means I break it up into these little pieces. Okay. P, true, true, false, false. Q, true, false, true, false. Not P is going to flip. So true, true, false, false will be false, false, true, true. And true, false changes to false, true, false, true. Connecting with and says I'm looking for two truths. So false, false is false. False, true is false. True, false is false. True, true is true. Okay. Let's talk quickly about truth values versus truth tables. Sometimes we have statements that don't require truth tables because we know the truth value of the statement. So for example, 8 plus 2 is 10, or 9 minus 4 is 3. We don't have choices there. 8 plus 2 is 10. That's true. 9 minus 4 is 3 is false. It'll always be that way. So I don't need a truth table when I know the value of a statement. When I put these together, I have my true or false. It becomes true. So all I did was substitute the value, 8 plus 2 is 10, true. 9 minus 4 is 3, false, with the connective of or to get true. Same thing here. Find the truth value of 4 is even and 6 is odd. 4 is even is true. 6 is odd is false. My connective and says this whole statement is false. So how about you try? Here's two more statements that you guys should know the truth value of. Fill in the truth values along with the connectives, and let's see how you do. All right, so here's what I get. 8 times 2 is 4, false. 7 times 3 is 15, false. False and false equals false. Tampa is in Florida, true. Orlando is not in Washington, also true. I put that together with or, and once again, I have a true statement. That's the end of our short video.